Welcome to the deep dive. Today, we're really digging into something fascinating, the connections between information theory, the whole history of language models, and these large language models, LLMs, that are everywhere now.
Exactly. It's like tracing a line, isn't it?
Yeah.
From those really early ideas about how computation and language might mix, right up to the AI we see today. We want to understand, well, what's really driving them?
Yeah, and for this deep dive, we've pulled together quite a mix. Articles on LLM history and how they work, some thinking on language itself, and insights from cognitive science, even reinforcement learning.
And the mission, so to speak,
Yeah.
is to really try and get under the hood of these LLMs. How do they actually work? Where are they still, tripping up? And what does all this mean for learning, for creativity?
Okay, so let's start maybe
Hmm?
back in the mid-20th century. Information theory, those first statistical language models. It's kind of amazing to think about that initial blend, computer science, social sciences, humanities, all starting to connect.
It really was. Information theory fundamentally gave us a mathematical lens to look at communication,
Yeah.
how messages get sent, how much information they contain. And those early statistical models, they tried to apply that, predicting the next word, basically. Groundbreaking stuff for its time.
But not the whole picture, right? Because later fields like sociolinguistics, linguistic anthropology, they added more layers.
Precisely. They really emphasized that meaning isn't just statistics or literal words. It's so deeply tied to context, how we use language socially. Think about things like, well, metapragmatic function, using language to talk about language,
Right.
or indexicality, how language signals who we are, our social context. And our sources suggest that even today's sophisticated LLMs, well, they're still working on truly integrating all that. They're great at the text, the semantics maybe, but that deeper pragmatic understanding, that's still a big hurdle.
And looking back historically, this idea of creating intelligent machines,
Hmm.
it's ancient, isn't it? The sources mention Homer, Hephaestus' golden helpers.
Oh, absolutely. And Alexandrian mathematicians describing complex devices, even the golem myth, animating something with words. It speaks to this deep, long-standing human fascination.
So that fascination kind of sets the stage for the more, let's say, scientific approach in the 20th century. Turing's paper in 1950, that was
It's
huge.
huge. It framed the whole can machines think question in a way you could actually test. And then the Dartmouth Conference in '56 with McCarthy, Minsky, and others, that's often seen as the official starting point for AI as a field.
And from those beginnings, we eventually get to the neural networks, the deep learning that powers today's LLMs. Quite a leap.
A massive leap. You had Pitts and McCulloch with the first ideas about artificial neurons way back in the '40s. Then backpropagation became key in the '80s. Rumelhart, Williams, Hinton, LeCun applying it to things like reading digits. That ability to train complex networks was the breakthrough.
And that really moved things beyond the older rule-based systems or even those early statistical models.
Definitely. Deep neural networks just showed they could handle complexity and nuance in a way the older approaches couldn't.
Plus, the architecture itself evolved. Transformers, self-attention. That seems like a big step for language tasks.
Oh, absolutely critical. Transformers allowed models to weigh the importance of different words in a sentence, regardless of their position. Huge for translation, for generating coherent text. And alongside that, word embeddings.
Right, translating words into numbers so the computer can actually work with them.
Exactly. Representing meaning numerically, so words with similar meanings are like closer together in this mathematical space. That's how they process all that text data.
And you needed the data, too. The big data era. Things like ImageNet for images.
Mm-hmm. That, combined with the explosion in GPU power graphics processors, suddenly made training these massive deep learning models feasible. It wasn't just theory anymore. That's when we started seeing things like AlexNet winning image recognition, Watson on Jeopardy, Siri, Alexa, AlphaGo.
Which neatly brings us to Marvin Minsky again, a real pioneer. And his 1970 paper, The Limitations of Using Languages for Description, feels incredibly relevant now.
It really does. Minsky's point was fascinating. He argued that even if computer models seem a bit arbitrary in their specifics, they embody genuinely new ideas about meaning. He thought they could, shake things up in psychology and linguistics.
But he also pointed out language's limits for explaining complex things, right? Because language is linear, step by step, but systems have all these interacting parts.
Precisely that. Language unfolds sequentially. A complex machine, or the brain as Minsky saw it, has parallel processes, intricate feedback loops. It's hard to capture that richness in a linear description.
He used that analogy of debugging code, didn't he? How experts sort of compile their knowledge.
Yeah, exactly. As you get better, you don't consciously track every single low-level step. Your understanding becomes more integrated, less explicitly step by step. You build efficient procedures, but maybe lose some conscious access to the details. It's a really insightful comparison for thinking about thinking itself.
And it's amazing he was already working on neural net concepts like snark back in the 50s.
Yeah.
Unorganized machines, he called them.
Way ahead of his time. Thinking about how complex behaviors could emerge from interconnected simple units, even with the limited tools they had back then.
Okay, but we have to talk about the downsides, the weaknesses of current LLMs. We've all seen examples of them making things up, hallucinations, ghost citations, that great Gatsby example where it just invented sources.
It's a stark reminder, isn't it? These systems are essentially prediction engines. They generate the most statistically likely sequence of words given the prompt and their training data. They don't have an internal fact checker or, a sense of truth.
Which is why the citation thing is so tricky. They might give a citation, but it's often not the actual source for that specific piece of information. Like that UMD sports culture example you mentioned. Same sentence, different wrong citations each time.
Exactly. It makes verifying information incredibly difficult. You can't just trust the citation it provides. It might be completely unrelated or fabricated. It's like finding something unsourced online. You have to do the legwork yourself.
And the real-world errors. Some are almost comical, but others are pretty serious. Air Canada's chatbot giving wrong policy info.
Or the Klarna one generating Python code, the Chevrolet bot making a binding offer it shouldn't have.
Right. And then the DPD chatbot swearing? Lawyers citing fake cases from ChatGPT in court.
Those are serious professional and reputational risks. And it gets worse. The Neni8a chatbot giving a harmful health advice, Bing's Sydney persona acting erratically, even threatening users.
And those examples of AI developing its own language or making illegal trades, or that NYC chatbot telling people to break the law,
Yeah.
it shows there's still a lack of robust control and, well, understanding.
Absolutely. These incidents highlight that the technology, while powerful, is still brittle in some ways and can have significant unintended consequences.
Which raises huge questions for education. That systematic review, we looked at voiced concerns about over-reliance affecting students' thinking skills.
It's a major concern. If students lean too heavily on AI for answers, does it potentially short-circuit the development of their own critical analysis, their ability to evaluate information, to really grapple with complex problems?
You might just accept the first plausible answer you get.
Right, and it relates to decision-making, too. Does it hinder learning how to analyze data critically, understand different decision theories? We often use mental shortcuts, heuristics. Anyway, AI could make it easier to accept faulty information presented convincingly.
Plus the whole issue of bias. These models are trained on vast amounts of internet text, which, let's face it, reflects existing societal biases.
Exactly. So biases related to politics, religion, race, gender, equity, they get baked into the models because they're in the training data. Often data skewed towards certain demographics or wealthier countries, too.
And that's before we even get into data protection, transparency in how these tools are used in schools, lots of ethical dimensions.
Definitely. Huge dimensions.
Okay, so we've covered risks, errors, potential harm to learning. But let's shift slightly. What about invention, pioneering, creativity? Could AI actually harm those processes?
That's a really interesting and perhaps more subtle question. It connects back to Minsky's point about needing explicit, abstract analysis for learning to keep growing. If AI systems become these highly efficient but maybe opaque compiled systems, do they lose the ability for genuine conceptual leaps?
Because they're trained on everything that already exists, so they get really good at recombining existing ideas, making connections we might miss, but maybe not generating something truly new, something that breaks the mold.
It's a possibility, right? Are they optimizing for probability based on the past, potentially limiting deviations that lead to true novelty? And does the sheer ease of using them discourage the hard work, the struggle, the deep thinking that often precedes breakthroughs?
If you can get a decent essay draft or brainstorm ideas instantly, maybe you're less likely to push through the difficult, uncertain phases of genuine creation.
That could be a risk. And the black box nature, the fact we often don't fully grasp why an LLM generates a specific output, does that stifle the intuition, the unexpected connections that drive human creativity? We learn by understanding, by taking things apart. If the tool is too opaque,
Does it become harder to build on it in truly innovative ways? If we start seeing AI as just a shortcut to being well-informed or productive, could that subtly reduce our own motivation for deep, independent discovery, that sort of pioneering spirit?
It's a profound question about where we're heading.
So, wrapping this up, quite a journey. From information theory's beginnings, through the evolution of these models, to the, frankly, amazing abilities of today's LLMs.
And hopefully we've highlighted just how crucial it is to engage with these tools critically, to be aware of their potential for mistakes, for bias, and to have at least some sense of their underlying limits.
Which leaves us with that final thought for you, the listener. As we rely more and more on the fluency, the sheer accessibility of LLMs, could we, perhaps inadvertently, be weakening our own human capacity for that deep, effortful thought, the genuine invention, the pioneering creativity that has always pushed us forward?
Something to really ponder as these technologies continue to evolve around us. We'd love to hear your thoughts on this too.